Good morning, everyone. On behalf of Civil Engineering Department, Jansen's Institute of Technology, I welcome you all for the online course on Artificial Intelligence in Civil Engineering. Artificial Intelligence. Artificial intelligence is the simulation of human intelligence processes by machines, especially computer systems. Artificial intelligence is a specialized system to understand intelligent entities, construct them, and make the process of decision making simple, quick, and efficient. Hence, artificial intelligence is a branch of science involved in the research, design, and application of time efficient projects. Artificial intelligence in civil engineering. Artificial intelligence is proving to be an efficient alternative approach to classical modeling techniques. Artificial intelligence refers to the branch of computer science that develops machines and software with human like intelligence. Many problems in civil and structural engineering are affected by uncertainties that cannot be solved with traditional methods. Artificial intelligence aids to solve such complex problems. In addition, the AI based solutions are good alternatives to determine the engineering design parameters when testing is not possible, thus resulting in significant savings in terms of human time and effort spent in experiments. It is also be able to make the process of decision making faster, decrease the error rates, and also increase the computational efficiency. Among the different artificial intelligence techniques, machine learning, pattern recognition, deep learning have acquired considerable attention and are establishing themselves as a new class of intelligent methods for use in structural engineering. The civil engineering problems are not repetitive, as the problem definition is always influenced by a number of factors like financial modes, importance of structure, and site conditions, so on. Therefore, although the use of computers in structural analysis started almost 4 decades ago, the profession has not been able to make use of computers fully, especially for structural design and planning. This is mainly because of problems such as specific nature, need for logical reasoning, feasibility constraints, and use of past experience required in actual design process and planning. Expert systems have capabilities to incorporate some of these requirements for programming a machine for solving a design problem. Artificial intelligence is a very versatile and potential technology in the field of computer technology, which enables computer users in various fields to solve problems for which algorithmic approach cannot be formulated and which normally requires human intelligence and expertise. Expert systems and artificial neural networks, the best known manifestations of artificial intelligence, have today gained immense credibility and acceptance in many professional fields. Intelligent optimization methods in civil engineering. Intelligent optimization methods in civil engineering. It is applied in expert system, artificial neural network, knowledge based system, intelligent database system, intelligent robot system. Artificial intelligence methods have been extensively used in the fields of civil engineering applications. Example: construction management, building materials, hydraulic optimization, geotechnical and transportation engineering. It is also used in the construction planners to generate and evaluate optimal or near optimal construction scheduling plans. The smart system refers to a device which can sense change its environment. Development of robots and automated systems. Artificial intelligence has many applications in civil engineering field. Structural health monitoring. Embedding sensors within structures to monitor stress and damage can reduce maintenance cost and increase the lifespan. This has been already used in 40 bridges worldwide. Self-repair materials. It involves embedding thin tubes containing uncured resin into materials. When damage occurs, these tubes break, exposing the resin which fills any damage and sets. Self-repair could be important in inaccessible environments such as underwater or in space. Structural engineering. In the field of structural engineering, they are used to evaluate durability. Not only the smart materials or structures are restricted to sensing, but also they adapt to their surrounding environment, such as the ability to move, vibrate, and demonstrate various other responses, as well as for monitoring the integrity of bridges, dams, offshore oil drilling towers, where fiber optic sensors embedded in the structures are utilized to identify the trouble areas. Waste management. Manual disassembly of the waste is a challenging, expensive, and time consuming task, but the use of smart materials could help to automate the process. Even it shows a role in food waste management. Characteristics of the mortar, coarse aggregate, and the interface. For the same quality mortar, different type of coarse aggregates, the concrete strengths can be determined. Suited for developing decision aids with analogy based problem solving capabilities in estimation. Analogy based solution to markup estimation problem. A methodology is presented and can be used to develop a practical model. The model design, training, and testing can be described along with the generalization improvements. An industrial process plant. This decision is based on several decision attributes which are divided into the following categories: plant location, environmental and organizational, labor related, plant characteristics, and project risks. The performance of the trained neural network system is compared with the recommendations provided by the human experts. Neural network system for vertical formwork selection. Neuroform is a computer system that provides the selection of vertical formwork systems for a given building site. The selection of an appropriate neural network model, its architecture, representation of the network training examples, and the network training procedures can be described. A statistical hypothesis test can be conducted on the recommendations of Neuroform when partial inputs are given, which demonstrates the system's fault tolerant and generalization properties. Belief networks for construction performance diagnostics. Belief networks are a form of artificial intelligence that incorporates uncertainty through probability theory and conditional dependence. A belief network can be developed by first defining the variables in the domain and the relationships between those variables. An automated approach for the improvement of the construction operations involving the integration of the belief networks and computer simulation can be described. Computer simulation is used to model the construction operations and also to validate the changes to the operation recommended by the belief network. Building knowledge based expert system for diagnosing pre-stressed concrete pile with artificial neural network. Diagnosis of damage of pre-stressed concrete piles during driving is an important problem in foundation engineering. The backpropagation learning algorithm can be employed to train the network for extracting knowledge from the trained examples. The artificial neural network works efficiently as a knowledge acquisition tool for the diagnosis problem. To apply the knowledge in the trained network, a reasoning strategy that hybrids forward and backward reasoning schemes is proposed to realize the inference mechanism. Construction Robot Fleet Management System. The application of robotic equipment to the execution of construction tasks is gaining attention by the researchers and practitioners around the world. Several Japanese construction firms have already developed their own fleet of construction robots. The utility of this system lies in optimizing the robot performance of work tasks on as many construction projects in a contractor's portfolio as possible. Thus, economic benefits of robot use can be achieved more easily. Thus, robot development costs can be recovered faster and robot use can be distributed over more applications and types of construction tasks. Modeling initial design process using artificial neural networks. The preliminary design model is of vital importance in the synthesis of a finally acceptable solution is a design problem. The initial design process is extremely difficult to computerize because it requires human intuition. But the development of a network for the initial design of reinforced concrete structures can be enhanced with artificial neural network. The network predicts a good initial design and the various stages of development and performance evolution with the respect of rate of learning, fault tolerance and generalization. Intelligent planning of construction projects. Knowledge representation and reasoning techniques derived from artificial intelligence research permits computers to generate plans, not merely analyze plans produced by humans. They explicitly represent knowledge about how to generate plans in the form of initial and goal states, descriptions of actions along with their predictions and effects. Bridge planning using GIS and expert system approach. In the planning process of a new road network, the planner should consider possible locations of bridges and tunnels. The selection of the best alignment imposes the need to investigate the effect of the location of each bridge on the bridge type that fits its location. This task has not been done so far because of the large volume of the data needed and the complicated interaction between many factors. Considering this task in the early stage of road alignment, planning can result in a more rational design. Geographic information systems and expert systems are proposed as two methodologies that can help in comparing the candidate sites and candidate type simultaneously. Having this computation power, quantitative comparison can be done faster and more precisely than in the case of conventional simplified methods. This can result in improving the design of the road network in general and in having bridges designed to meet the requirements of erection, maintenance, driving comfort and landscape. Next is artificial neural network approach for pavement maintenance. The main objective is to assist decision makers in selecting an appropriate maintenance and repair action for a defected pavement. This can be typically performed through collecting condition data, analyzing and selecting appropriate maintenance and repair actions. Artificial neural network for environment health safety. For environment health safety, there are multiple areas where artificial intelligence can contribute. When robots carry out tasks in construction, the human errors can be minimized. Tidal forecasting. Tidal level record is an important factor in determining constructions or activity in marine areas. Earthquake induced liquefaction. During the occurrence of earthquakes, numerous civil structures such as Buildings, highway embankments, and retaining structures have been damaged or completely destroyed. The damage of civil structures occurs in two modes. The first mode is that of structural failure, and the second mode is that of foundation failure caused by liquefaction. Therefore, estimation of the earthquake induced liquefaction potential is essential for the civil engineers in the design procedure. Artificial intelligence immensely helps in the design of structures to safeguard against the earthquake. Expert systems and artificial neural networks are the best manifestations of artificial intelligence. Expert systems are applicable to a wide range of tasks and many problems in civil engineering domain such as structural design, structural modeling, structural diagnosis, site investigation, estimation, scheduling, or potential expert applications. Developing an interface mechanism demands very high programming skills, particularly for developing a general expert system shell which can be used for diverse types of applications. The developed expert systems eliminate the tedious procedure of referring to the charts, graphs, and tables of IS codes and helps the user to arrive at final quantities of cement, water, sand, and coarse aggregate per cubic meter of concrete. For example, the expert systems in artificial intelligence can be used to determine the safe bearing capacity of the soil, to select the suitable foundation, and also to determine the axial loading of the column, and also to determine its moment, etc. Expert systems can also be used to find the magnitude of the imposed loads for different spans of slabs, beams, etc. The development of knowledge based systems will not only permit the retention of expertise but also its logical extension as well as to access the expertise by other structural engineers. Developed expert systems for analysis and design, concrete technology, design of RCC, structural steel components, and the use of artificial neural networks in non destructive testings can also be enhanced. Developed expert systems in the field of construction technology are not only used by the engineers during the laboratory but also used in the commercial testing of material. The development of knowledge based systems will permit not only the retention of expertise but also its logical extension as well as access to the expertise by other structural engineers. Artificial neural networks. Artificial neural networks are defined as systems that solve complex problems for which doesn't exist sequential algorithms, only examples of solutions, and which generate their own rules of learning. Artificial intelligence can also be used to solve the problems in the field of building materials, their behavior, geotechnical engineering, structural identification and control, heat transfer problems, transport infrastructure issues, management and technology in construction and installation issues. Artificial neural network in non-destructive testing. The artificial neural network in non-destructive testing enhances the behavior of structural members with and without reinforcement. It also enhances the behavior of structures with different types of reinforcement. For example, with and without reinforcement, in the case of a deep beam, considering the input as its length, shear span, span by the depth ratio, and percentage of the fiber content, etc., can be related to give the five outputs. Example, maximum experimental moment at failure and theoretical maximum moment. To facilitate the rapid assessment of flexural behavior, multi-layer feed-forward artificial neural networks can be trained to learn the relationship between input and output data generated from the available experimental data. The error correcting backpropagation algorithm can also be used to map the relationship. Application of artificial intelligence using Artificial neural network in civil engineering field. Designing, planning, construction and management of infrastructures, estimation of building. Artificial intelligence in structural design. Design can be viewed as the general process in which an idea is developed into detailed instructions. The activities that follow can be grouped into four phases: synthesis, analysis, evaluation, optimization. Synthesis: the clarification of the input parameters and their interaction to create a structure that will meet design requirements. Analysis: the modeling and solving of equations to predict the response of a selected structure. Evaluation: the activity of placing a worth on the structure where worth may be cost, safety, or energy consumption. Optimization: the search over the range of possibilities of improving the design as much as possible. Today, CAD in structural engineering involves almost exclusively analysis, proportioning of structural components, and production of drawings and schedules. There are very few applications to conceptual and preliminary design. Conceptual and preliminary designs are considered the creative aspects of design. Yet, generally, the preliminary design process is not new design but redesign, where the redesign involves the application of existing structural ideas to a particular design. New design implies the development of a new structural configuration, example, new concepts in structural design. Redesign actually is the application of a set of rules to assign values to predefined variables. Thus, it appears that preliminary structural design process may be placed in a knowledge-based system where if then rules are used to instantiate values in a data structure. A knowledge-based program is developed using the knowledge of experts. Once a program is developed, there should be close interaction between the designer and the computer. The computer should be able to respond to the queries on the design process as well as accept additional information. Since a design prepared by the computer follows a limited number of rules, close supervision by the designer is necessary. In this way, the designer will realize inadequacies in the existing set of rules and make revisions or additions to the rules when necessary.
Objects, no, in models. As you can see, the majority of the elements have been already classified. We can modify or amend. If we click on edit, we will access to the specific menu of the classification. For example, select one item of the model which has not been classified yet, and we'll see that the machine gives us a level of in high strength concrete. We can select this one from the list and assign it directly. If we do the same steps, and the calculation will be as accurate.
Artificial neural network in high-rise buildings. The need for high-rise buildings is increasing in order to meet the challenges posed by rapid urbanization and the exponential growth in population. With recent advancements in computing technologies, innovative materials, and new structural systems, the need of prior knowledge about proportioning the geometry, configuration of structural members is also increasing. A relatively quicker and reliable estimation of approximate sizes of members can greatly facilitate the preliminary design and feasibility of the project. The construction of taller structures becomes more challenging with increasing height, serviceability, strength, and sustainability of a tall building are most important parameters to be considered during building construction, which can be obtained by detailed analysis and design process. These processes are divided into many phases such as conceptual designing, preliminary designing, modeling, analysis, final design, and detailed designing. The preliminary design of tall buildings involves detailed mathematical justifications and expert knowledge. It is a tedious and time consuming work. Hence, to overcome such issues, and to utilize the experience based obtained from available data, we can use the artificial neural network. Artificial neural network is a type of machine learning tool which consists of massive parallel computational model that intimates the function of a brain. It uses learning algorithm to model and save the knowledge in weighted connections. Artificial neural networks have been used in many structural engineering related works in past, such as structure control using neural network, predicting dry shrinkage of concrete using neural network approach for cost estimation of structural systems. Implementation of artificial neural network in buildings. The neural network can be developed by the structural engineers to perform preliminary design of buildings. They can feed in set of input data and train the network and then use it to predict the output for further unknown input data set. The input parameters can be taken from the architectural data of the building to predict the structural design of the building. The designer can select data from either performance based design or code based design to predict the building design of new buildings. Artificial intelligence for better design of buildings. For better design of buildings, building information modeling can be used. Building information modeling is a 3D model based process that gives architecture, engineering, and constructional professionals insights to efficiently plan, design, construct, and manage buildings and infrastructure. In order to plan and design the construction of a building, the 3D models need to take into consideration the architecture, engineering, mechanical, electrical, and plumbing plans and the sequence of activities of the respected teams. Project planning of buildings. The model allows construction planners to generate and evaluate optimal or near optimal construction scheduling plans that minimize both project time and cost. Artificial intelligence also helps in the development of robots and automated systems. Even the role of artificial intelligence is also reported in the case of smart materials. Artificial intelligence holds the key to solve late and over budget construction projects. It can assess endless combinations and alternatives based on similar projects. It aids in project planning since it optimizes the best path and corrects itself over time. Artificial intelligence in architecture. Artificial intelligence will make an architect's work significantly easier by analyzing the whole data and creating models that can save a lot of time and energy of the architect. Artificial intelligence can be called an estimation tool for various aspects while constructing a building. Artificial intelligence will make the planning process of the architects significantly easier, giving them access to countless amounts of data, creating models, interpreting the building environment, and creating cost estimates. All this information can be easily conveyed to the architect to help shorten design and building time. Artificial intelligence in building information modeling. Advanced construction potential building information modeling is a software that helps in 3D designing and modeling, useful in architecture, engineering, and construction operation industries. Algorithms used by artificial intelligence reports every flaw on the construction sites as it can identify different buildings by their structure, size, and location. information modeling for planning and designing. Building information modeling BIM is a 3D model based process used by architecture, engineering, and construction experts in order to reduce the design errors, to reduce clash detection, and to improve the integration of design and construction phase, and to enhance recycling. The database represents the exact geometries, shapes, colors, textures, physical property, codes, and other attributes of all building components. It portrays the connection between mechanical, electrical, and plumbing, heating, ventilation, and air conditioning systems of various structural components. In a realistic construction pattern, the whole building project is first constructed visually to solve all possible installation problems, manage procedures, and conflicts before starting the actual construction. As a result, mistakes are avoided that can be detected at an early stage.
These days, a growing number of architects, engineers, and contractors are using BIM. And here's why. Global trends are making AEC projects more complex, while advances in technology are helping industry professionals work more efficiently and effectively. This is where BIM comes in. BIM is an intelligent model-based process that connects AEC professionals so they can more efficiently design, build, and operate buildings and infrastructure through BIM, or Building Information Modeling. With BIM, designers create digital 3D models that include data associated with physical and functional characteristics. The power of BIM is how it allows architects, engineers, and contractors to collaborate on coordinated models, giving everyone better insight into how their work fits into the overall project, ultimately helping them to work more efficiently. The data in a model defines the design elements and establishes behavior and relationships between model components. So when an element in a model is changed, every view is updated, with the new change appearing in section, elevation, and sheet views. You can use the information in the model to improve your design before it's built. Gain faster buy-in and approvals with realistic visualizations. Convey design intent to the field. And, most importantly, retain model intelligence from concept to construction. BIM provides insight into a design's constructability, improving the efficiency and effectiveness of the construction phase, and also providing a better understanding of the building's future operations and maintenance. Owners can use BIM for predictive maintenance, asset tracking, and facilities management, and for future renovation or deconstruction projects. When you work with BIM, you'll experience reduced project risk, improved timelines and cost savings, and better project outcomes. And the power of BIM is growing with cloud-connected technologies that let project teams design and work together in all new ways. Driven by global trends, the AEC industry is in a time of transformation. Businesses that want to win more work, deliver projects more efficiently, and design better buildings need a powerful solution. And that solution is BIM.
Similarly, the software also finds elements of a building, for example, windows, doors, slabs, stairs, and walls, by applying their attributes such as usage, structures, and functions. Further, it also predicts the information such as the amount, expenses, schedules, materials, and can analyze data based on the structure and ambience. Artificial intelligence in interior design of buildings. Tasks in architectural and interior design range from defining the building floor plans and ensuring desired functionality to decide the furnishing styles and arrangement choices. The process of design as a whole has remained hard to master for computer based optimization in general, and for computational intelligence approaches in particular.
Drones, virtual reality, robots, lasers, artificial intelligence, 3D printing and scanning. How can all these new technologies help design the buildings of tomorrow? In search of answers, architects have teamed up with engineers, and their findings have been shared at this exhibition here in the capital of Denmark. Hosted by the Danish Royal Academy of Fine Arts, the exhibition was organised around the work of 15 researchers who used the latest digital tools to explore new horizons in architectural design. Models were developed using materials such as clay, filaments, concrete or wood. Among the new ideas on show, structural platforms in carbon and glass fibres, wound by robots able to generate complex, resilient, multifunctional geometries. Or energy in facades, thus providing a kind of environmentally friendly, energy-efficient, soft robotic skin for future. And how can we safely, accurately bend glue-laminated timber to create new, unexpected architectural spaces? Motion capture techniques and 3D and laser scanning technologies were used to examine new wooden geometries and morphology. The exhibition was the fruit of a European research project aimed at linking simulation, materials and designs to imagine a future where more and more buildings will need to be built with fewer and fewer materials and in sustainable ways. Researchers say many of these solutions could be integrated into real buildings within 5 years.
We are now arriving at a time when the cities of any country will define the future of its economy, and infrastructure will be the fuel for its growth engine. But on this road to growth, many challenges need to be addressed. And therefore, the need arises for a complete paradigm shift. One that opens up new business avenues with immense potential for engineering and construction companies. All powered by digital transformation to drive never-before efficiencies in cost, speed, and quality. Wipro's blueprint for engineering, construction, and operations focuses on 4 future themes: reimagining design, build, and operation, DBO machines, personalization, and new economy, encompassing all assets, contractors, equipment, and manpower, leading to a modern operational model that opens a new era in construction practices. With DBO machines, you can leverage automation, artificial intelligence, and real-time insights and foresights to provide a significant operational advantage. With personalization, whole new avenues of customer service and brand equity open up. And finally, with new economy ideas, you can embrace business disruption with revolutionary business models that can outthink the competition. All these bring to fore the power of industrialized construction that also prioritizes a human-to-human approach rather than B2B or B2C. It's all possible right here, right now, by adopting and deploying the concept, be digital, build digital. An idea whose time has come. It totally connects the ecosystem for standardized processes, operational efficiency, work-winning agility, and generating newer operating models. With live digital solution prototypes that back our thought leadership, Wipro is now showcasing not a proof of concept, but a future that's yours to win. A future whose foundation is built on a strong, innovative, and smart design process, backed by our world-class in-house team. Design it, from vision to conception and beyond. You're invited to digitally transform your business with Wipro.
The field of artificial intelligence attempts to understand intelligent entities as well as construct them to make the operation reasonably simple and easy, correct and precise. Artificial neural networks are typical examples of a modern interdisciplinary subject. Artificial neural network makes the civil engineering field more accurate, precise, and efficient, especially in the fields of smart materials and designing. Thank you.